I want to look at the derivative of this function here, x raised to the x power. Now, I've taught calculus many, many times, and I get to this problem and I ask people, how do you think you take the derivative of that? Now, some people say, oh, that looks like a power rule. That looks like an x to the n. And so the derivative of x to the n, they know, is nx to the n minus 1. So they look at this thing and they say, oh, the derivative of x to the x should be x times x to the x minus 1. Right? Just treat them just like that. The n comes down in front and you subtract 1. But then I have some students that say, no, wait, this looks more like an exponential function. This looks like the derivative of a to the x. Let's see if I can write that a little better here. The derivative of a to the x. I may need a new stylus here pretty soon. That's a to the x times the natural log of a. And so they say, okay, what I have is the derivative of x to the x. So that should be, boy, come on now. That should be x to the x times the natural log of x. So where this a is here and here, this x now is here and here. It's like, well, is it an exponential function or is it a polynomial function? Or is it kind of a little both, or is it really neither? The power rule only works for x to a constant power. That's when the power rule works. The exponential rule here only works when you have a constant raised to the x power. So this is neither strictly polynomial, strictly exponential. It's kind of both, it's kind of neither, and we got to do something different to take the derivative here. So these I got question marks on. This is sort of the first guess of what people think is going to happen. What I'm going to do is I'm going to use logarithmic differentiation to turn it into something I can handle that I've worked with before. So if I take the natural log of both sides, natural log of y equals x times the natural log, whoops, let me not skip that step, is natural log of x to the x, right, just taking the natural log of both sides. And I'll use the properties of natural log here to break this up a little bit. Natural log of y equals x times the natural log of x, right, because that power can be written out in front as a multiplier. Now this is a product, and I can do a product rule here. So here we go. I'm going to take the implicitly differentiate with respect to x. Derivative natural log y with respect to x is the derivative of x ln x with respect to x. This side, derivative of natural log with respect to y would just be 1 over y, but I didn't want it with respect to y, I want it with respect to x. So the chain rule says multiply by dy dx. And then on this side, I've got a product rule. I've got x times the derivative of the natural log plus the derivative of x times the natural log. So first times the derivative of the second, second times the derivative of the first, add them up. So I've got dy dx here equals y times the x times 1 over x is just 1, and then the 1 times natural log of x is natural log of x. And what is y? Well, y is the function we started with. It's x to the x. So I'll plug that in right here. I've got x to the x times 1 plus ln x. So what is the derivative? It's this. But while I'm here, I'm going to actually multiply that through. This is x to the x plus x to the x ln x. And one thing that jumps out at me is like, whoa, wait a minute. This bit right here was that bit right there. And the other thing that's there, that's not immediately obvious, but the x times x to the x minus 1, that's actually equal to x to the x. Just got the same base, add the exponents. So this right here is that piece up there. And it turns out, the question of is this polynomial or is this exponential, the answer is yes, it's both, and the derivative has both pieces to it. Main point here though, I've got a function that I don't have a derivative rule for. Okay, but by taking the log of both sides, I can break it down into things that I do have derivative rules for. I know how to take the derivative of the product, I know how to take the derivative of x, and how to take the derivative of log of something. Likewise over here, I know how to take the derivative of log y. So I turn something I don't know into something that I do know using logarithmic differentiation here. Okay, there you go.